Hello, this is Anthony with Copley. Today I'll be showing how to use QModMaster. I have a BE2 here loaded with Ethernet firmware. I believe all the Ethernet firmware is available on our partner resources page. But it looks like this. BE2 ENET 4.48 is the version I'm using. So what does that do when you load the Ethernet firmware? Well, it gets rid of all the EtherCAT firmware and it puts in special Ethernet capabilities. So with Ethernet you can talk TCP IP, Modbus, TCP, and a bunch of other Ethernet protocols. So if we get the network options parameter, we see that this bit is set bit 9, and that's how you can tell that it's Ethernet firmware. If it was EtherCAT, this would not be set, it'd be 0 for this register. So now it is the drive has a it has that bit set, but now I need to configure the IP address. So my adapter has IP address. Well, let's see what it has. So if I go to the command prompt and I just do ipconfig all here, you can see that it has 192.168.0.100, the IPv4 address. So I'm going to pick an address that's on that network, but is unique, different. So I'll say set r0x11f. So 11f is the parameter for the IP address in the drive, and we'll say 1 and then 88C0. So what I just did is I set it to be 192, which is C0, 88 is 168, 0, and then I gave it a unique IP address with this last byte, 1. So that means that it's now on the network, but it has a unique address. So the first 3 bytes have to match in order for it to be on the network. So the master should also have the first 3 bytes matching, but then the last byte would be unique. So I just saved it in RAM and flash using this, using R, and then also using F for flash. So now I can go ahead and close the ASCII command line, and I'm going to open up the QModMaster. QModBus is available. You can Google it, and you'll find it here on sourceforge.com for a free download. It's just an executable, and it's very easy to use. So I'm going to be referencing an app note. If we go to support and general resources, go to app notes, scroll down to 133, find the Modbus app note. So now, what's next? Let's see. So let's open up QModBus. QModBus. There it is. Okay. QModMaster. So first I have to connect to the drive. So I go to Options and Modbus. Let me reset the drive here. Okay. So right now it's listening for the correct port, so that's good. 192.168.0 and then 1. So that's the slave IP address that's in the drive, and it's listening to 502, which is the correct port. You have to be listening to 502. So yeah, I hit the connect button and it found it and it connected. And so I'll be running through various commands in the following video. Okay, now we will make a move with CME. So if we go to the oscilloscope and we go to the Profile tab. Next we go to the Tools and Communications log. I'm doing that so that I can see the messages that CME sends. So we have the Enable Logging checkbox checked. And hit Start. Then I can uncheck the Enable Logging checkbox because I only really care about the first few commands. So we can see it made a nice move there, a relative trap move. So the commands that it sends, if we look here, are setting the desired state to hex 15, and then it sets the position, the commanded position, to 28B0A. So CA is the ASCII parameter for the commanded position. Likewise, the desired state is 0x24. So the Modbus parameters for those would be 24 times 2 is 48. So, and then whatever CA times 2 is 190 something. And then the trajectory profile mode, it sets that, because we selected trap relative, it's hex 100. So parameter C8 is hex 100. And again, we'll multiply that times 2 for the, and then for the Modbus parameter. And then it sends later on a start move command, which is just a T1 command. So that's those are the parameters that CME sends to make a move. Alright, so now we're connected still over serial with CME, but we're connected to the QModMaster. So hit the little connect button up there. So yeah, so those commands, we're just going to replicate them in the QModMaster. So the first command, let's set the desired position. So CA times 2 equals 194. So 194. And then we're going to write to multiple registers, and we're going to write this value in there. So just do a write command, and you can see that that successfully sent, and there were no errors. We will go ahead and do the next command. So C8 times 2, 190. So C8 was the ASCII parameter for the profile type, which was, relative trap move. So do 190, and it QModMaster is nice in that it tells you what's already inside of the register. So hex 100 was correct. That's what we're going to write there. And notice how we're writing 2 registers, not just 1 for this, because this parameter is assigned to 16-bit registers. So yeah, that went through, and now we will go ahead and do the next parameter, which was the desired state. So 0x24 is the desired state, times 2 is 48, and we were setting that to be, so right now it's 1E. For position program, though, we're going to change that to be 15, hex 15, which is 27 in decimal. And yeah, let's write that. Okay, now we'll send the T1 command. So in the app note, talks about register 2000, which is used to perform a trajectory function. So we'll just send a 1, and that'll start the move. So if we go here, say 2000, and actually for this, you don't want to do multiple registers. You just want to do a single register, because if we go back to the app note, the very next register in memory is for CVM sequencing. So for CVM programs. So we don't want to address 2001. So single register. Let's go ahead and put a 1 in there. And then before I send the go command, because that'll start the move, I want to go ahead and monitor that it actually worked. So here's the position. See what happens. Oh, okay. So yeah, every time I click on that T1, every time I click send here, you can see it's updating. It's changing making that move. So yeah, that's how you make a move using QModMaster. So the next thing we'll talk about is addressing long parameters, so parameters that are longer than 32 bits. So you just add a, you address this range here for those parameters. So what you do is first you write the parameter to that address 1000, and then all the data after that, and then you will read that same hex 1000 address, and you'll get back the value that you just wrote. So in this app note, it talks about the output config. So I'll show you what that is in CME. So right now I'm connected to a BE2, and right now we're talking to access B. So I'll go to the outputs here, and we'll configure output 1 to be custom position triggered, and then we'll say the lower limit is, let's see here, pick a number that is easily understood in hex of 4660, and then the upper limit will be, let's say 5678. So 5678 22136. Okay. So now if I go into the ASCII command line and I get that value, so .b for access B, get R0x70 in hex, we see that this is actually what's in that register, these three data words. So this corresponds to custom position triggered, and then these are the actual positions that we're going to be triggering on this window here. So how do we do this with QModMaster? So let's go ahead and go to QModMaster. And so I selected write multiple registers, start at address 1000, and then let's go to the second, so unit ID 2, because I'm talking to axis B, right? So axis 1, or axis A is unit ID 1, axis B is unit ID 2. If I had multiple, more axes, it's pretty straightforward. So first you write to 1000, you write the parameter, so 70 is output 1, and then 4 for the position window, and then the positions after that. So so actually in this case, what we will be writing is for the lower limit, it'll be 6, 7, 8. It'll be this lower limit, and the upper limit will be, let's see, 2, 3, 4, 5, 6, 7, 8, 9. So 23. So let me see. Oh, I did the wrong. That's in decimal. Let's see here. X 2, 3, 4, 8, 9. Okay, there we go. So 500. So 300 million to 590 million, roughly. So in counts. So yeah, we just say write, and then that's it. So now I'm gonna, if I wanted to read that, I'll read the holding registers starting at 1000. And then, let's say, oh, I don't know how many I need to read. I'll just read it. Oh, wait, I'm missing data here. Okay, well, how much data are you missing? Well, this number actually represents how many words of data after this word. So there's 5 more. So I have to add 1, 2. I have to add 2 to 5, which is 7. So 7. And there we go. So that's all of the data. So again, now if I go to the ASCII command line, I do .b get r0x70 in hex. We can see that command worked. Yeah. Okay, the next thing we'll talk about are the CVM registers. So we have CVM control programs in the drive. If we click on this tab here, open up the CVM screen. So if we have a program in here, then we can start a program or change the program depending on these values. So go to the register values tab. So view register values. And we can see that we have 32 registers in here. Each of them is 32 bits long, and on power up they're initialized to value 0. So R0 to R31. So that's a live feed of the registers. So in the app note we talk about addressing these registers. Their range is in Modbus is hex 3000 to hex 303F. So if you want the first 16 bits of a particular register, this is the formula you use, and then the next 16 bits is, plus 1 for that. So plus hex 3001. So say I wanted R5, it would be 5 times 2 is 10, and then you'd add that to hex 3000. So the number 10 in decimal is the letter A in hex, so it'd be 300A for the first 16 bits, and the next 16 bits would be 300B, because we're adding that 1 there. So let's see here. So R5 is 300A. I just need to address the first 16-bit register. And then I'm going to select, writing multiple registers. And then I'll say 2 registers here. And then we will pick a value to write. So let's write 500,000. That's a good number. So I'm going to write this value in here, 7A120. 7A120. I'll hit write. And there you see it, R5 is 500,000. So you might be thinking, wow, this is cool, but it's kind of hard to change each parameter one at a time. Well, actually, with QModMaster, you can write multiple registers, and that can be expanded. You can think any register that is contiguous in memory, you can address multiple registers with one command. So, for instance, because the CVM registers are allocated from starting address 3000 to 303F, as we saw here, we can address all of them at once with one command. So I just wrote a little block here, this one message that'll address all of them and set them all equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's this value 1, 2, 3, 4, 5, 6, 7, 8, 9. So I just send this command, and they all get set. So yeah, that's how you use QModBus Master. I hope this was helpful.